So for group D, which is the choose any two questions, questions 3 from labs 13 or 14, or lectures 13 or 14, I'm sorry. For my first question, I chose from lecture 13, question 3C, which was using the luminosity flux relation of F equals L divided by A. Calculate the flux of a light bulb if Y joules per second is its luminosity and its surface area is 0.012 square meters. So I brought my whiteboard back for this. Just for the meantime, ignore the bottom portion. So we know that the equation is F equals L divided by A, where F stands for flux, which according to the formula is measured by dividing L by A. L stands for the luminosity, which is measured in joules per second. And A is the surface area, which is measured in meters squared. So they give us the surface area, which is 0.012 meters squared, which would go on the bottom half for our A. And they said our luminosity is equal to Y joules per second. And for me, my Y value is, my Y value is 14.4. So I would plug that in on the top half of my equation. So you're left with an equation that looks like this over here. So you would get 14.4 joules per second. Divide that by 0.012 meters squared, and I got a nice clean number of 1,200 watts per meter squared. So that was question 3C of lecture 13. Moving on to lecture 14, which was where I got my next question. Question 3B, what is the flux of the sun in units of watts per square meter on a satellite X million meters away from the sun? So just real quick, to recap, the solar flux, F, of a certain distance, d, on a satellite is given by the rotation. So for this equation, for this question, I use the equation F equals L divided by 4 pi d squared, where L is the luminosity of the sun, which we know to be 3.8 times 10 to the 26 watts, and d is the distance of the satellite, the distance the satellite is from the sun, which they tell us is x in millions of meters, and my x is 144, so it's 144 million meters. So we just plug that into the equation. We put the luminosity on top, 4 pi, and the distance squared, and then you would get an answer of this, but this doesn't look good, so I converted it into scientific notation and got 1.46 times 10 to the 9th power watts per meter squared as the answer. Thank you.